Educational data mining originated from the analysis of log data capturing student interactions with computers, with a strong emphasis on understanding students and learning contexts. Until 2005, research in this domain primarily centered on relationship mining methods, followed by predictive methods. Despite being rooted in data-driven analysis, educational data mining consistently placed a strong emphasis on learning and teaching, directing research towards data mining and machine learning techniques aimed at enhancing web-based learning environments for educators. The widespread adoption of VLEs and learning management systems empowered educational institutions to manage an increasing volume of data related to user interactions and academic information. This integration of learning analytics with VLEs and LMSs, such as Blackboard and Moodle, provided educators with valuable insights into student engagement, performance, and learning outcomes, paving the way for more personalized and effective teaching practices. However, the surge in big data within the education sector also presented its own set of challenges. As educational institutions grappled with the exponential growth of data, they faced significant hurdles in terms of data management, analysis, and interpretation. Students, on the other hand, encountered new challenges in the online learning environment, ranging from feelings of isolation to technical issues and a lack of personalized support. Despite these challenges, learning analytics, coupled with artificial intelligence, emerged as a powerful tool for educators to navigate the complexities of modern education. By leveraging advanced analytics and machine learning techniques, educators could gain deeper insights into student behavior, personalize learning experiences, and optimize educational outcomes. Over the past couple of years, we've witnessed an incredible expansion in the field of AI. Models like ChatGPT, Stable Diffusion, Whisper, and DALL-E 2 have revolutionized the way we interact with technology. These AI systems are not only capable of handling multiple tasks simultaneously, such as vision and language processing, but they're also enhancing large-scale learning. Now, let's delve into the goals of learning analytics. They include building better educational methodologies, empowering active learning, reaching at-risk students, and assessing factors influencing student success. Learning analytics and artificial intelligence serve as powerful tools for educators. They enable us to acquire detailed information on student behavior and performance, personalize teaching based on individual needs, and identify areas where difficulties may arise. Leveraging data on teaching practices, teachers can create a more effective and tailored educational experience for each student. They can also use data to enhance learning, allowing it to progress in line with the continuously evolving world. But before we proceed further, let's take a brief digression to understand the categories of deep learning and machine learning, which are subsets of artificial intelligence. Deep learning, in turn, is a subcategory of machine learning characterized by neural networks. The depth comes into play when the neural network involves more than 3 layers, including input and output layers. Whether learning is labeled as deep or automatic depends on how each algorithm learns. Deep learning automates much of the feature extraction process, reducing the manual human intervention required and enabling the use of larger data sets. Classic, or non-deep, machine learning relies more on human intervention to hierarchically organize features in understanding differences between data inputs, typically requiring more structured data for learning. Deep learning can utilize labeled datasets contributing to what is termed supervised learning. It can also use raw data, such as texts or images, and automatically determine the hierarchy of features distinguishing between different data categories. In this sense, deep learning presents itself as scalable automatic learning. Generative AI refers to deep learning models that can take raw data and learn to generate results as needed. Generative models have been used for years in statistics to analyze numerical data. The exponential growth of deep learning has made it possible to extend this capability to images, speech, and other types of complex data. Variational autoencoders, VAE, introduced in 2013, were among the first class of models widely used for generating realistic images and speech. Deep learning can transform into adaptive learning, providing personalized resources and learning activities tailored to specific needs. Ultimately, adaptive learning is an educational method that uses computer algorithms to organize interaction with the learner, providing personalized resources and learning activities tailored to specific needs. This does not mean creating diversified lessons for each individual, but rather envisaging a learning path with numerous possible options, leading to specific assessment outcomes. Structurally, digital learning comprises small, autonomous learning units that adapt to each student's needs. These units are activated or deactivated based on individual progress, utilizing algorithms, including artificial intelligence systems. This strategy ensures that learners follow a specific logical sequence, with the system automatically selecting the best path and presenting only relevant content. The advantage for the user is twofold. They save time by not studying what they already know, and they maximize training time by focusing on relevant content. From the educator's perspective, it's crucial to recognize the diverse characteristics and learning needs of students. The adaptability of materials ensures that each student can access customized learning paths, enabling them to achieve their set goals. This is the ultimate mission of digital learning, enabling everyone to learn at their own pace effectively while maintaining high levels of satisfaction. With augmented intelligence, we attain the speed and scalability of artificial intelligence and machine learning, but solely to enhance what an individual is trying to achieve. Therefore, it is essential to set aside any prejudices feeding the fear that machines will become more intelligent than humans, to the point of rendering them useless. Instead, we should reassess the capacity of AI to support diverse teams, facilitate the review of large datasets, identify and remove biases before they are transformed into large-scale actions. And that concludes today's lesson. Thank you for joining me.